Hello students, and welcome to the CompTIA Network+009 Exam Course brought to you by Third Level Technology. I am your instructor, Jim Herby. In this episode, we're going to continue in Module 1 in the exam objectives. We're going to discuss Section 1.2. Our topic is Network Appliances. Let's begin. A router is a network device that works at OSI Layer 3. The router is going to be OSI Layer 3, which is our network layer. Routers are the network devices that allow our internal local area network to communicate with other external networks and the public internet. Within your business or organization, all of the devices, printers, computers, servers, and others that are contained within your local area network will have their own internal private IP address. This will be the IP address that all the devices use to communicate with your routers as well as other devices on your local area network. In IP addressing, the most common addressing format we use is IP version 4, IPv4. And IP version 4 has had all of the available IPv4 addresses be exhausted and assigned across the globe. Because we have many more computing devices in relation to IPv4 addresses, with routers, we use a technology called Network Address Translation, or NAT, N-A-T. Network Address Translation is when our routers will have a singular IP address that it uses to communicate to outside networks and the public internet on behalf of all of the internal devices. Whenever an internal device on our local network wants to communicate externally, it will send a data request to our router. And the router will then send that data traffic request out to the external internet using the IP address assigned to the router. This is network address translation. Then when the router receives incoming traffic, it can then forward all of the appropriate traffic to the local device using the locally assigned IP address. Routers are able to keep updated records using a routing table. This is where it will keep records of all of the data that goes to our internal devices, as well as to external networks and public websites on the internet. Our next network device is a switch. A switch is a OSI Layer 2 device. OSI model, this is the data link layer. Switches are devices that allow all of our local area network devices to connect all of our Ethernet connections to a single device. This allows all of our devices to send and receive to each other on our local area networks. Our switches keep MAC address tables. Your MAC address is your media access control address. This is an identifier that is placed on all of our network devices' network interface cards. And our switches will keep updated MAC address tables so that when data is being sent to and from locally on our network, it can keep track of the appropriate source and destination. With switches, we also have the capability to do virtual local area networks. You will see this commonly abbreviated as VLAN, V-L-A-N. A virtual local area network is when we take all of the configurations and monitoring of our network infrastructure and we place its configuration and management in a software application. This allows us as an administrator to manage and configure all of our network devices through a single software interface. Our next network device is a firewall. Firewalls are devices that allow us to do traffic filtering. This is when we can inspect and monitor all of the incoming and outgoing traffic on our network. Firewalls can be standalone hardware devices, or they can be software configurations that we use in our virtual networks. We create firewall rules that will specifically identify what types of traffic will be allowed or denied in our network. With our firewalls, we can configure these rules with many different types of criteria. We can create firewall rules based on port numbers, protocol types, as well as specific types of applications, Firewalls also will be commonly integrated with IDS and IPS systems. IDS is intrusion detection system. IPS is intrusion prevention system. These two types of systems commonly work with our firewalls to help us monitor and filter our traffic. An IDS, intrusion detection system, is when we use software to monitor all of our network traffic for suspicious activity. IDS systems use signature-based detection. This is when we will use digital signatures that are commonly used with both websites as well as commonly known malware and viruses, so that when one of these types of files or IP addresses is flagged by our IDS, it can send an alert and notification to our administrative staff to address the issue. An IPS goes a step further. This is intrusion prevention system. An IPS is when we can do active mitigation to isolate and remove the security threat or malicious file. IPS allows us to do things such as quarantining. This is when we can isolate a file in real time on our network. We can also do real-time blocking or web IP that becomes alerted through our security systems. Next, we're going to discuss a load balancer. A load balancer is a device we use in our networks to allow us to evenly distribute traffic to multiple servers for specific tasks such as email, web databases, and others. And what a load balancer allows us to do is to configure all of the traffic that is coming into our group of servers evenly. So as a request comes into, say, an email server, our load balancer can take all of the requests and evenly distribute them across the available servers. Load balancers also can do real-time modifications, so that if one of our servers becomes unavailable or is undergoing maintenance, the load balancer can adjust the distribution of traffic to the remaining available servers. Load balancers are very scalable, adjust up or down the way that we distribute traffic. If we have a specific server that may be operating at a very slow speed or that is temporarily unavailable, the load balancer can adjust the traffic to the remaining servers in real time, as well as sending us alerts and notifications about the problems. Next, we're going to discuss a proxy. A proxy is a device that we normally place somewhere near the perimeter of our network or near to our routers. And it allows us to control user access internet-based content. With a proxy, all of the web requests that are going in and out of our network will be sent through the proxy to make sure that they don't violate any of our security rules. Our proxies will be configured with the same firewall rule lists that we use to monitor internal network traffic. Proxies are very helpful because they allow us to do what's called masking. Keep all of the internal IP addresses of our users anonymous. This helps to enhance our security for our internal network because outside hackers and unauthorized third parties can't have access the IP configurations of our internal users. Next, we're going to discuss network attached storage, or NAS, NAS. This is when we have a device that is connected to our network that provides file level storage for all of our network users. This is where we can keep and store all of the data and information that we want to have accessible to our users across the network. A network attached storage typically will require our users to have a username and password. And we can also use techniques such as redundancy and RAID to help us to increase the amount of available storage. We'll talk about RAID in more detail in a future episode. Next, we have storage area network. And a storage area network is a little bit different because it is going to be an isolated segment inside of our local area network where we allow our devices to do block level storage. If we have any type of enterprise level applications, many times we will use a storage area network to provide the storage capacity for this type of information. And instead of accessing information at a file level, we do it at a block level. This is so that we can avoid high latency and still have pretty good speeds as far as accessing that type of data. Our next network device is a wireless access point. Commonly, you'll see this abbreviated as WAP, or called a WAP. A wireless access point is a device we use to allow users to connect wirelessly to our hardwired Ethernet network. So if you're in a business or organization that uses wired Ethernet, all of those connections are going to terminate at a switch or a router, and all of those internet connections are going to be sent and received through the Ethernet cabling. A wireless access point takes the hardwired internet capability and extends it or acts as a bridge to a wireless network. If you're ever in a building or public space that has a public network, take a look up high on your walls or maybe the ceiling and look for square-shaped devices. These will be your access points. They allow us to have a consistent wireless network signal across a large space. And the wireless access points will communicate with each other to make sure that we don't have any breaks in our signal coverage and range. Your wireless access points also act as the authentication point for our users, and they can access the wireless network using an SSID, a service set identifier. This will be the network name that we give to our wireless network, and then our users will authenticate with a correct password. Related is a wireless controller. We talked about a switch earlier. A switch is where all of our Ethernet cable connections can terminate in one location. A wireless controller acts similarly, but it does so with all of the wireless access points. When you place your wireless access points throughout your buildings, they connect to our network through an Ethernet cable that connects and terminates at the wireless access point. All of these cable connections for our wireless access points will terminate at the wireless controller. This is going to be a single device. Typically, you might have this near where you have your switch and routers, to where all of the access points throughout your building can connect to that one device. And this is how all of your wireless access points can share configurations as well as receive configuration and security patches and updates. Next, we have a CDN, a Content Delivery Network. And a CDN is going to be the structure that we use with our servers to make sure that we can distribute streaming and web content to our users in a very fast and low latency time. If you work for an organization or a business that has office locations across the United States or maybe even internationally, content delivery networks are very common. Take your servers that you use and place them strategically nearby all of your regional offices and locations. And then you can use your geographically placed servers as the way to send and receive traffic for applications and real-time streaming services. CDNs work with load balancing, so you can use load balancers at your distribution sites. Next, we're going to discuss VPNs, Virtual Private Network. A VPN is a technology we use to allow remote users to connect to our internal private network through a secure encrypted tunnel. Typically, you will install VPN software on your remote users' devices, and they can use that VPN software to authenticate to our internal network resources. Once a user has authenticated correctly in their VPN software, our internal network will create an encrypted tunnel with the remote user, and all of the traffic that's being sent to and from the remote user will be encrypted. VPNs allow us to mask our users' IP addresses, prevent eavesdropping because all of the traffic is in encrypted form. And lastly, we're going to talk about two different network configurations we can use: quality of service and time to live. Quality of service, or QoS, is when we can prioritize certain types of network traffic to our available bandwidth. Commonly, we can use quality of service for things like voice over IP phone systems, real-time streaming applications, and other things that we want to give priority to the bandwidth available on our network. With quality of service, we're trying to give priority to the most important types of traffic, and the most sensitive types of data. Quality of service can be configured both in our routers and switches, as well as in our filtering tools like firewalls and access control lists. Your time to live, or TTL, is when we set a number of hops that a data packet can go on the network before it is dropped from our network. Every time you send a data packet through a router, that is called a hop. And with time to live, we can set a limit on how many different routers we want a data packet to transfer through before we drop it from the network, as well as to avoid network congestion, because any misrouted data packets will eventually be removed from our network. That will conclude our discussion of Section 1.2 Network Appliances. In our next episode, we will move on to Section 1.3 in the exam objectives, and our topic will be cloud computing. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.